All right then. So a couple of slides on matching engine, and then we'll do a couple of slides on tune. So we go through this fairly quickly. But so the matching engine is an off-the-shelf component, which is designed to be the backbone of an exchange. So it's the core functionality which provides the matching, validation, and risk checks. And throughout the design, the focus has been on modularity. Okay, so different exchanges will typically have quite a bit of bespoke functionality as differentiators between one exchange and the other. And also, we want the framework to be common across asset classes. It needs to be asset class agnostic. So the same framework should be able to work with across different asset classes. So for that, we really have sort of a high degree of modularity across the whole library application stack. To allow us to plug and play different functionality for different use cases. So out of the box, we support multiple order types. So for example, markets, limits, stops, icebergs, pegs, and hidden orders. And one of the things to take away from that is not necessarily the surface support for the different order types, but also what that means for the implementation. So we've got fully virtualized layers within the order books to give us the flexibility to support that kind of variety across the order types. That's baked in from the ground up. Gives us a lot of flexibility on the type of features in terms of order types that we can offer. And there's a similar story with the matching controls. So we've got fully configurable matching controls out of the box. We offer self-match prevention, minimum execution quantity, and it's again a highly modular framework where different matching controls can be plugged in as needed. Fully scalable, fully distributed architecture, all built on top of Chronicle Q as the foundation. So again, we've got fully production hardened HADR and high performance baked in from the foundations. As I touched on, it's a common framework for the simple addition of services, and what we mean by that is that from the core matching engine, you can then add on a whole bunch of auxiliary feeds off the same core components. So the classics are market data feeds, drop copies, aggregation services, etc. You can add very flexibly the different components as needed. And again, because this all leverages Chronicle Q, and we've got the replicated copies of Q or the sequencer framework, this is an extremely flexible architecture in terms of where you place your components. So, for example, you may want your market data feeds to be on different resources, so you're not stealing the resources across market data high performance, and your matching engine high performance is very flexible to move the components around as necessary to make maximum use of your available resources. Supports fix and native gateways out of the box again. So with fix, you've got familiarity and wide support across the industry, but it does come with some dents in terms of absolute lowest latencies, just because of the nature of the protocol itself. It's a fix specific thing. So very often you'll see native gateways offered as well as the lowest latency offering for any particular exchange. So we recognize that, and the matching engine interface will seamlessly support both fixed and native gateways, depending on the offering for any particular use case. And as we touched on in the earlier section, the matching engine has been available in Rust in Java for some time, and it is now available, or will be functionally complete and available towards the end of this quarter, and it's a 100% pure implementation of Rust. So as we touched on, so it's designed from the ground up for low latency, fully integrated from Chronicle Q, and it gives us a lot of the easy integration, easy modularity, easy bespoke feature implementation from one use case to the next. And also, crucially, it's just as easy to deploy on-premise as it is in the cloud, vice versa. And again, with crypto in particular, they're driving the cloud adoption very aggressively, and that's where we have a good footprint with the matching engine already. Fully deterministic and built off comprehensive automated test coverage. So this again is baked into the design from the ground up. So it's very easy to get very high levels of automated test coverage, which of course is what you're going to want for something as mission critical as matching engine. And today, as things stand, with the Rust implementation and the Java implementation, we're both sub-microsecond matching latencies. So the plot on the right-hand side, the blue plot shows the core matching engine itself, which is what you would achieve with native interfaces. Layering on Fix interface, because of the nature of Fix, as I touched on earlier, necessarily brings some additional overhead, but it's again the modular framework allows you to plug and play the different components very easily. But even out to the 4 nines with the core matching engine capability, where low single-digit microseconds in matching and sub-microsecond through to probably the 99th percentile. So Chronicle Tune is something that we wrote internally as in we wrote for internal use a few years back. And what we were using it for was, obviously we spent a lot of time tuning software, tuning servers, doing benchmarking and performance testing. And the standard tools for tuning a machine with low latency have various challenges. There's no single tool that does everything you want, and even using the tools that are standard in the Linux space has certain drawbacks in some cases. So that was the motivator internally for putting together something which really was a one-stop shop for machine tuning. So it allowed us to cover all of the ground we needed in a single package. And the core design goals for us was to really simplify quite low level powerful system tuning. It sort of democratizes the tuning of your Linux hosts. So once we had that, and we were discussing it with clients, they became very interested in Tune itself. So it became a very natural component to fully productize. So what Tune provides is a single, easily configured interface for CPU isolation, IRQ management, power management, disk tuning, and kernel threads. So again, the real takeaway with Tune is it does all of this in one very easily configured package. So for example, there are tools out there which do CPU isolation. There are tools out there that do IRQ management, disk tuning. This is all collected into a single easily used package. And even where there are standard tools, some of those tools have fairly important caveats, right? So the classic is ISIL CPUs, very powerful. However, it does have certain downsides. So you need to reboot the machine each time you change the configuration, for instance. And also there are complications with using ISIL CPUs with range-based controls like task set and shed set affinity. So those are two of the big things with Chronicle Tune that we use to displace ISIL CPUs. So Chronicle Tune is fully dynamic. You do not have to balance the machine when reconfiguring the CPU isolation. And all of the standard tools, range-based task sets, shed set affinity, all of those still work completely naturally with Chronicle Tune. Okay, so this is a big usability benefit versus ISIL CPUs. Another important, excuse me. So another important difference with C groups, for instance, and C sets is C sets and C groups tend to drive you more towards control of individual processes rather than threads, whereas with Chronicle Tune, you can think right down to the thread layer. Okay, so you've got total control. Or we expose total control over the application stack. We don't, it's not an opinionated tool. It doesn't drive you into any particular direction. If you want to control down to the thread level, you absolutely can do that seamlessly with Chronicle Tune. So it's very much a partner tool for your low latency environment. And although we'll be talking about isolation replacement with Chronicle Tune as one of the headline pieces, Chronicle Tune is doing an awful lot more than that. So we'll compare it against ISIL CPUs and C groups. as a headline feature, but we're doing an awful lot more than just CPU isolation. So again, it's a big differentiator between those two standard tools. So in terms of performance, the plot on the left-hand side shows the jitter on an untuned versus a tuned machine. So what we're doing here is we're running a tool which measures the interruptions to a running process on a particular core. And what we'll see with the untuned case is, first and foremost, the horizontal axis is somewhat split, so it's more or less linear halfway, and then it goes logarithmic. Okay, so by the time we go out to the far right-hand side, we're into big jitter events. Okay, so these are events that will stop your application for of order milliseconds. The number of interruptions, number of delays is also a logarithmic scale. Okay, so by the time we get up to the top end, we're orders of magnitude more than the lower end. So where we want to be on this plot is tucked up as much as we can in the bottom left-hand side. And that's exactly what Chronicle Tune is doing. So with an untuned box, you've got interruptions out to milliseconds, and even there, you're going to have a couple of hundred. By the time you get down to the single-digit microseconds, which will hurt, outlier performance, you're talking hundreds of thousands of interruptions per second. Per hour. Whereas with Chronicle Tune, first of all, most importantly, we cap the jitter events. Okay, so these high impact multi-microsecond, multi-millisecond events have disappeared entirely. Okay, so we're capped at 6 microseconds, but also the number of events has come right down. So we've come down by 2 or 3 orders of magnitude for the number of events as well. So what this is showing is you're running with a much cleaner machine. So the question then is, well, how does that translate into application performance? So this is what we're showing on the right-hand side. So the before tuning is the light blue line, after tuning is the dark blue line. And what we're seeing is that although there's commonality in the lower percentiles, as you'd expect, we then begin to diverge quite quickly at the higher percentiles. Okay, so what we're doing with Tune is nailing off these higher outlier, these higher percentile events. So we're running with a much cleaner application stack. So that's going to translate into sort of much more consistent latencies with lower jitter across the applications. Here's I won't go into detail on this, it's just a comparison between Chronicle Tune, ISIL CPUs, and C groups. And again, the big takeaway is it's not just isolation. Chronicle Tune is doing a lot more than just isolation. Isolation is the sort of one of the main interaction points with Tune, but we're doing a lot more besides, in terms of IRQ management, kernel parameters, and disk tuning, for instance. One of the things we are looking to do with Chronicle Tune going forwards is have a guided optimization mode. So at the moment, Chronicle Tune is a tool which helps you tune your machine. So you have a rough idea of where your application wants to run, the resources it's going to need access to, and then you can use Tune to easily configure that. The next stage is guided optimization, where essentially you will run your stack with Tune observing your stack, and then Tune will make recommendations that become an opinionated tool to sort of give you recommendations for how you could configure your stack to get the maximum benefit from it. This is something we are looking to potentially build through next year. Okay, that is a link to a video, which we won't play right now, but that's something that is in the pack, and you'll be able to look at the demos. It's about a 5 or 6 minute video. It's just demos how easy it is to use Tune. So we reconfigure a machine multiple times, so without bouncing, to just sort of show how easy it is to manage the environment.